Hi everybody, I wanted to run through on page 453, problem number 17, because I think that it's a little bit hard to sort of just read the answer. It makes a little bit more sense if you can see how the problem sort of develops. So I would suggest drawing it. In order to draw this, because it says north, 60 degrees north of east, you do have to sort of establish where north and east are. So if we say that this is obviously due east and this is north, then 60 degrees north of east is basically 60 degrees above due east, because north is up. So it'd be like drawing a 60-degree angle in standard position. So this is essentially 60 degrees north of east. And the magnitude of this vector, or the distance that that person traveled, is 4.5 kilometers in that direction. Then from that point, and this is where tip to tail and knowing how to add vectors on a picture is helpful. That's all this is. We're just going to add these two vectors. So the snowmobile is right there. And then from that point, she makes a turn. But the turn is south of east or below east. So if you kind of redraw your due east line, this is straight east, or back to 0, 0 if you want to think of it that way. If you want to reset up your coordinates and you put your new origin right there, that's another way to do it. We want to think about going south of east or below east, and we're going to go 30 degrees below that straight line, or that 0-degree line if you want to think of it that way. So this is where the 30 degrees is. But if you think about how that would look on the coordinate plane, we would call that 330 degrees or negative 30 degrees. So it's up to you how you want to call it. I'm going to refer to it as negative 30 just because it seemed like a better angle to type in than 330, but 330 would also work. And then, of course, the magnitude of this vector is 6.5. So it's a little bit longer. My picture is obviously not drawn to scale. So for part A, in problem number 17 here, we want to figure out, if she turns and drives straight back to the cabin, what direction should she head? All right, so that question is basically saying if we turn around and go right back to the cabin, which is not really tip to tail anymore because your resultant should look like this, but basically she's heading back to the way she came. We are essentially looking for this little angle right in here. So in order to figure out direction, we have to find the components. So we're going to resolve this to the components by doing the magnitude, 4.5 times the cosine of the angle. I'm dealing with the vector that I drew in black there, and that is 60 degrees. And then the y value of that is 4.5 times the sine of the angle, which is 60 degrees. And to that, we're going to add the red vector. Now, the red vector has a magnitude of 6.5. And, of course, x goes with cosine. Now, remember, we're calling that negative 30 degrees. Or you could call it 330, up to you. And then the y value is 6.5 sine of negative 30. When you add these two up, you can put them straight into the calculator, but you're going to add the x's to the x's, and then you're going to add the y's to the y. So make sure you're in degrees, and then you're going to get your component form at 7.88 and 0.647. Now we can finally answer the question. So for direction, we know we use tangent. I'm going to continue to call it alpha, and it's just b over a. Remember, this is a and this is b, so it's 0.647 over 7.88. And that gives you 4.7 degrees. Now, the direction in which this would be is if we think about putting our coordinate plane there. This is the little angle we just calculated. So that is, here's west, south. So if we think about our compass again, that is going to be below or south of west. Or if you wanted to That's really the best answer, because it's basically in the same kind of explanation that the whole problem is in. So that's probably the best way to do it. Now for part B, you're asked to find how much time will the trip take to return. So again, how much time would it take to go along that green vector to get back to home? So we're talking about 20 kilometers per hour, and the answer is asked for in minutes. Well, we don't really have the ability to calculate time with what we know. We do have the ability to calculate distance though. So the magnitude or the distance of that green vector, I'm going to just call that vector v, is going to be the square root of a squared plus b squared, 7.88 squared plus 0.647 squared. Throw that in the calculator and you get 7.90. Combine that with distance equals rate times time, and we'll be able to calculate the time, because this is the distance. We know the rate is 20 kilometers an hour. So when we go to divide this, you're going to get hours. This is 0.395 hours. Well, the question was very specific and it said to round to the nearest minute. So multiply that by 60 and you end up with 23.7 minutes, but we want to go to the nearest minute, so that's 24 minutes. Now this process is one that we will do again. The process being, take a word problem, resolve it into the component form, and then figure out direction and magnitude. The conversion of all these units, that's not really something we deal with a whole lot. Usually our units are pretty straightforward, but it is the rest of it that you will see again. I hope this helps, and if you have questions about any other problem, let me know. I can make a quick video, or we can find a time to meet. Just get in touch with me and just let me know what works for you.